All right, to finish up this lesson, I'm actually going to bring in a couple more figures to this diagram here. So I'm going to bring in line S and point M. We need point M for our one postulate for this lesson. So again, a postulate's an unproven statement that doesn't need to be proven because it just intuitively makes sense. All of these theorems are things that we can prove, and we may be proving later in this class. But let's just look at postulate 10, also known as the parallel postulate. Through a point not on a line, like M, and and we're talking about a line, Q, because we're mentioning a line. So there's a line and a point not on a line. Through M, there exists exactly one line that is parallel to Q. So through a point not on a line, there exists exactly one line through the point that is parallel to the line. I want you to think about that for a second. Could I draw a line that is parallel to Q through point M? And yes, I can. Parallel lines are coplanar, so it'd have to be coplanar with Q. I could draw a line that's in the exact same direction as Q. But I'm sort of locking in the direction of that line so it's in the same direction as Q, and it goes through point M. I'm locking it through point M as well, right? Now, can I draw another line through point M that's parallel to Q? Well, other than that original line I just drew, you can picture where that line would be. There's no other line that I could draw. Because if I draw something in a different direction, it's not going to be parallel to Q anymore. It's going to intersect with Q somewhere. And if I draw something that's not through point M, I'm not using the postulate anymore. Like, it has to be through this particular point that's coplanar with this line, and the line through it has to be coplanar. So there's no other line that satisfies. There's only one parallel line through a point compared to some reference line, some original line. All right, and that's the parallel postulate. Does that one make sense after you do a little bit of thinking about it? Again, there's just multiple figures you have to hold in mind at the same time, and that's kind of what makes this a little difficult. Theorem 5.7, the last one. If two lines are parallel to the same line, then that means that those lines are parallel to each other. I'm just going to make a statement. I'm going to say that Q here is parallel. Let's say that S is parallel to Q. And I know that P is already parallel to Q. So if I'm making the statement that S is parallel to Q, and I know that P is parallel to Q, can I say that P is parallel to S? The answer to that is yes. Yes, you can. And the reason for that is because parallelism does two things. It locks in the direction, means that the lines are essentially moving the same direction, they're never going to cross. And it locks in that the lines are coplanar with one another. Parallel lines have to be coplanar. So if I'm saying that Q and P are in the same plane and they never cross, and S and Q are in the same plane and they never cross, that means that because S and Q are in the same plane and Q and P are in the same plane, S and P also have to be in the same plane. And S and P aren't going to cross each other because they're in the same direction, just like Q and P were in the same direction and S and Q were in the same direction. So I'm locking in direction. I'm locking in that they're coplanar, that coplanar status. That means that they're going to be parallel to each other as well. S and P would be parallel to each other as well. Okay, that's our list of theorems and postulates. Do you see what I mean? These ones are a little more complicated. Even if they don't make sense to you yet, as you work with them, they will. And that's what we're going to do. We're going to start working with some of these theorems and postulates as we do the lesson practice for lesson 5 in the next video.